The universe is an immensely vast space. Hidden within it are countless mysteries that humans have yet to decipher. Therefore, the exploration of the universe is always intriguing to scientists. And for those who love astronomy, have you ever dreamed of sitting aboard spacecraft traveling at the speed of light to explore the cosmos? I think you have. It's not just your dream, it's the dream of humanity's scientific endeavor. Today, I will help you realize that dream. First, let me introduce you. This is a future spacecraft named SpaceScience. It can travel at a speed of 300,000 kilometers per second, equivalent to the speed of light. And this will be the vessel to take you on a journey to the far reaches of the universe. Mr. Tubo asked for permission to be the captain and guide for you. I would like to remind you all that our journey will take a lot of time and encounter many obstacles. If you truly endure these challenges, you can still change your decision now. But if you are ready to embark on this journey with SpaceScience, please fasten your seatbelts to begin the journey. Welcome aboard to our journey to the far reaches of the universe on the spacecraft named SpaceScience, just launched from the launch pad named the Sun, the sole star in the solar system. The reason SpaceScience has its launch pad here is because this is the center of the solar system. As our journey begins here, you will have more accurate views of the universe. Of course, this is a hypothetical spacecraft of the future, so you shouldn't worry too much about it originating from the sun and traveling at the speed of light. Let's focus on the journey it will take us on. Please note that on the right corner of the screen is a clock indicating the time we've traveled, also considered as distance in the universe, measured by the time it takes for light to travel. We've been underway for about a minute now. The SpaceScience spacecraft is currently 18 million kilometers away from the sun. At this distance, you can see our sun appearing as a massive ball of fire. Of course, at this position, the spacecraft is subjected to intense heat from the sun. But don't worry, the SpaceScience spacecraft is equipped with a special heat-resistant shell that can help us withstand the tremendous heat generated by the sun. Here it is, folks. Can you see it? That's Mercury, the closest planet to the sun in the solar system. Mercury experiences the greatest temperature variations among all the planets in the solar system. During the day, temperatures can soar up to 427 degrees Celsius. But at night, they plummet to minus 173 degrees Celsius. This is truly a harsh environment in the solar system. Mercury's orbit is a narrow ellipse, with its perihelion point about 70 million kilometers from the sun, and its aphelion point about 46 million kilometers from the sun. This contributes to the extreme temperature difference on Mercury. And to fly the spacecraft through Mercury's orbit, it only takes us less than 4 minutes to do so. As we pass Mercury's orbit, we are heading towards Venus, Earth's sister planet. To reach Venus, our spacecraft will take about 6 minutes. This is because Venus has an orbit distance from the sun of about 108 million kilometers. Although Venus is the second planet from the sun, it is known as the hottest planet in the solar system. Temperatures on Venus can reach up to 470 degrees Celsius. Most scientists believe this is due to the predominance of carbon dioxide in Venus's atmosphere, leading to a significant greenhouse effect that heats up the planet's surface. An interesting fact is that from Earth's perspective, Venus is the brightest planet observed with the naked eye, reaching its greatest brightness near sunset or sunrise. Hence, it's commonly referred to as the evening star when it appears at sunset and the morning star when it appears at sunrise. After passing Venus, we will immediately see the beloved home of all living creatures. That is Earth, the only planet known to have life as of the present time. The SpaceScience spacecraft will take about 8 minutes to travel from the sun to Earth. From this vantage point, our Earth looks truly beautiful, doesn't it? Because this planet is very familiar to us, Mr. Tubo won't introduce it too much. Currently, we have been on the journey for about 10 minutes. At this point, we start to see Mars, the fourth planet in the solar system. It's often referred to as the red planet due to the presence of a lot of iron oxide on its surface, giving it a distinctive red appearance. Many believe that Mars once had water and harbored life. Some even speculate that life on Earth originated from Mars. The truth behind these stories remains highly debated, but it's fair to say that the red planet remains one of the most intriguing celestial bodies of all time. Additionally, Mars boasts Olympus Mons, confirmed as the tallest mountain in the solar system. To reach Mars, it will take us more than 12 minutes, as Mars is approximately 227 million kilometers away from the Sun. Please remain calm. That's an alert when the spacecraft encounters the minor planets of the solar system. Currently, we are passing through the asteroid belt, located between Mars and Jupiter. We will traverse it for about 8 minutes, from minute 19 to minute 27, as this belt expands from 2.3 to 3.3 astronomical units, AU, equivalent to the distance from Earth to the Sun. This region is known to harbor thousands of minor planets larger than 1 kilometer and millions of smaller objects. Despite their vast number, the total mass of this asteroid belt is 1,000 times less than Earth's mass. Our spacecraft is designed with a robust outer shell, so these minor planets pose no threat to us. Please remain calm, sit back, and enjoy observing this asteroid belt. Beyond the asteroid belt, we're on our way to Jupiter, the 5th planet from the Sun. To reach Jupiter, the spacecraft will take about 43 minutes to travel the distance because Jupiter is approximately 778.5 million kilometers away from the Sun. Although Jupiter is a gas giant, its mass is only about 1/1000 of the Sun's mass. However, it's 2.5 times the total mass of all the other planets combined. That's why Jupiter is often called the big brother of the solar system. Look, there's NASA's Juno spacecraft currently active, exploring Jupiter. It's sending back high-quality images of Jupiter's activities. On Jupiter, there's a prominent storm known as the Great Red Spot, which has been present for over 300 years. Its size could fit about 3 Earths within it. It's the eye of the storm. Now you'll have about 36 minutes to rest before the spacecraft heads to Mars. Here we are, we've reached Mars. It took the spacecraft 1 hour and 19 minutes to fly here because Mars is approximately 1.433 billion kilometers away from the Sun. You can observe prominently on Mars a beautiful ring. This is the widest ring belt among all the planets in the solar system. Interestingly, the outer circumference of the ring belt can be equal to the distance from Earth to the Moon, but it's only about 20 meters thick, earning it the title of the solar system's ultra-thin ring belt. Additionally, on Mars, a day is equivalent to 10.5 hours on Earth, but a year is nearly 3 Earth years. That's why, if there were a dream, Mr. Tubo would only hope to live for 3 Martian years, which would be fantastic enough. Now we are about 2 hours and 40 minutes away from the Sun, traveling at the speed of light, which means we are about 19.23 astronomical units, AU, away from the Sun. At this distance lies the position of Uranus, the 7th planet from the Sun. Uranus has the coldest atmosphere among all the planets in the solar system, with its extreme temperatures dropping to as low as minus 224 degrees Celsius. Certainly not an environment for those who fear the cold. An interesting fact about Uranus is its significant axial tilt of about 98 degrees. Because of this, the north and south poles of the planet are almost located at the equator compared to other planets. As a result, the 2 polar regions receive more solar energy than the equatorial region. Next up, Mr. Tubo invites you to travel to the 8th planet from the Sun, which is Neptune. To reach Neptune, the spacecraft will require approximately 4 hours and 10 minutes, as Neptune is located about 30 astronomical units, AU, away from the Sun, equivalent to about 4.5 billion kilometers. Neptune is the 4th largest planet in terms of diameter and the 3rd largest in terms of mass. It is also the planet with the highest density among the gas giants in the solar system. At this distance, as we look back at the Sun, it begins to appear smaller and fainter. Mr. Tubo reminds you that starting from this point onwards, the SpaceScience spacecraft will display time differently. This is because the journey from Neptune onwards will be an extremely long one, extending to the very edge of the universe. Please fasten your seatbelts as we prepare to enter an area where collisions may occur frequently. As the spacecraft passes through the orbit of Neptune, we will begin to enter a region known as the Kuiper Belt. This is an extended belt ranging from 30 AU to about 50 AU from the Sun. To traverse this belt, the SpaceScience spacecraft will require over 2 hours of travel time. As you can observe, this region contains numerous dust particles and fragments. Scientists believe that this is the origin of short-period comets, such as Halley's Comet. According to estimates by scientists, there are around 70,000 objects with diameters larger than 100 kilometers within the Kuiper Belt. However, the total mass of the Kuiper Belt is thought to be relatively small, approximately equivalent to or slightly larger than Earth's mass. And that is Pluto. This is a former planet of the solar system, considered part of the Kuiper Belt. Defined as objects within the belt having orbits similar to Pluto's are called plutinos. Within the Kuiper Belt, there is a distinct gap at approximately 49 AU, where we are currently flying through. At this position, the number of observed objects decreases significantly. Some scientists argue that it may have been cleared by some force, possibly the 9th planet of the solar system. So, observe closely. Who knows? You might be the first to discover the 9th planet of the solar system. Flying through the Kuiper Belt, we have quite a long time to rest. Now, after 174 days of travel, we are beginning to fly into the Oort cloud, a cloud with a diameter of about 1 light year. This means that the spacecraft will take more than half a year to fly through it. This area is quite peaceful, with only dust and gas. And of course, as you can see on the screen, the spacecraft has changed its clock interface for easy observation. Oh, the spacecraft has an alarm again. I wonder what we'll encounter. Look, there's an ancient object about 20 kilometers in diameter. Don't worry, our spacecraft will automatically dodge these objects as we fly through the Oort cloud. Perhaps we'll have the opportunity to encounter similar objects a few more times. Scientists believe that in the Oort cloud, there are billions of objects larger than 20 kilomilers in diameter, and perhaps trillions of objects larger than 1 kilometer in diameter. However, due to the vast space of this cloud, the chances of encountering these objects are quite low. Do you see anything? It seems like this area is very empty. Perhaps we've already passed through the Oort cloud. Currently, the time on the clock indicates that it's been over 3 years since we started moving. Perhaps the size of the Oort cloud is similar to what scientists predicted.
Look, there's the Alpha Centauri star system, the nearest star system to Earth. This star system is about 4.37 light years away from our Sun. As seen by the naked eye from Earth, it's a single star. But at our current position, you can easily see that it's a triple star system. Among them, the main binary system is Alpha Centauri AB and a red dwarf star, Proxima Centauri. In this star system, Proxima Centauri, the red dwarf star, is the closest star to the Sun. It's at a distance of up to 13,000 AU from the main binary system Alpha Centauri AB, and the closest distance is 4,000 AU. The special thing about this red dwarf star is that scientists have discovered 2 exoplanets orbiting it at distances of 0.05 AU and 1.5 AU respectively. Among these 2 planets, Proxima Centauri b is notable. It has a mass about 1.27 times that of Earth, but its orbit lies within the habitable zone of the host star, where water could exist in liquid form. The outer planet is named Proxima Centauri c. It's a super-Earth with a mass 7 times that of Earth. Scientists assess that this exoplanet is unlikely to be habitable. Scientists speculate that at a distance of 0.029 AU from the host star, there might be another planet with a mass equal to 30% of Earth's mass, but they have not yet discovered it. Keep a close eye. Who knows? You might be the first one to discover it. As for the binary system Alpha Centauri AB, they have an elliptical orbit with a period of about 80 years. In this system, the primary star A has a radius 1.23 times that of the Sun, and it shines 1.5 times brighter than the Sun. Meanwhile, the secondary star B has slightly smaller mass and size than our Sun, and its brightness is only equivalent to 50% of the Sun's brightness. After passing through the Alpha Centauri star system, we will proceed directly to the brightest star in the sky, which is Sirius. By now, we have traveled a distance of 8.65 light years. When mentioning Sirius, you must be very familiar with it because it's the brightest star in the night sky when observed from Earth. At this point, you can easily recognize that it's a binary star system where the primary star Sirius A has a very bright A0 spectral type, shining 25.4 times brighter than the Sun. In terms of size, it has a radius 1.71 times that of the Sun. Accompanying it is a very small star, with a diameter equivalent to that of Earth, but a mass equivalent to the Sun's. That's why it's a very dense star, classified into a rather unusual spectral type, Da2. With this spectral type, it has a very high temperature of up to 25,000 Kelvin, but its brightness is only 5.6% of that of the Sun. After passing through the Sirius star system, we will have quite a long rest period before reaching the star Altair. At this point, we have traveled a distance of 17 light-years. Altair is known as the 12th brightest star in the sky when observed from Earth. Currently, you can see that it's a white star with an A7V spectral type. With this spectral type, Altair has a fairly high surface temperature, ranging from 6,900 to 8,500 K. The most notable aspect of Altair is its incredibly fast rotation speed, estimated to be up to 286 kilometers at the equator, causing it to complete a full rotation in just 9 hours. Compared to the Sun's rotation period of about 25 days, Altair spins at a staggering rate. Therefore, it's named Altair, which means poet's star. Despite not being very large, with a radius only about 1.6 to 2.3 times that of the Sun, and its brightness being only about 10 times that of the Sun due to its proximity to Earth, Altair appears very bright when observed from here. It is one of the 3 stars that form the Summer Triangle, along with Vega Star and Tianjin Star. Now, of course, we will head straight to the star Vega. It will take us about 25 years to travel to its position. Although it's quite far away, in terms of brightness, it ranks 5th in the sky. Vega also has an A spectral type, with a surface temperature reaching up to 9,000 K. Therefore, it shines 40 times brighter than the Sun. Additionally, Vega is quite large, with a radius 2.36 times that of the Sun, but its age is still very young. According to calculations, it is only about 456,000 years old, which is equivalent to 1/10 of the Sun's age. However, scientists predict that with a size 2.36 times that of the Sun, Vega may only have a lifespan of 10% of our Sun's. Passing beyond Vega Star, we are now en route to the giant star Arcturus. This is an orange-yellow star, located about 37 light-years from the Sun when observed from Earth. Its brightness ranks 4th in the night sky, with a radius 25.4 times that of the Sun. Consequently, the star shines 170 times brighter than the Sun due to its large radius. However, the mass of the star is estimated to be equivalent to that of the Sun. Therefore, scientists believe that it may have depleted its hydrogen core, and its outer layers are expanding. It will continue to do so until the core collapses into a white dwarf star, and the outer shell will eject material into the surrounding environment, forming a nebula. Passing beyond star Arcturus, we will fly past many other stars outside of the solar system on our journey. We will encounter many interstellar gas clouds and dust in the regions between stars. Currently, we are at a distance of about 139 light-years from the Sun and near the star Actionis when observed from Earth. This star ranks 9th in brightness in the night sky and is a binary star system, with the primary star having a B6 spectral type and the companion star having an A spectral type. The distance between these 2 stars is 12 AU. The most notable feature is that the primary star has a surface temperature of up to 15,000 Kelvin. Additionally, it has a large size, with a radius about 7.3 times that of the Sun, emitting a brightness 3,150 times that of the Sun. Therefore, when viewed from Earth, this star appears very bright. Now we are at a distance of about 315 light-years from the Sun. At this position, we have reached the star Canopus, a very famous star in the night sky. Its brightness, when observed from Earth, ranks 2nd only to the star Sirius. Canopus is a white supergiant star with a spectral type of F. With this spectral type, it has a surface temperature of around 7,350 Kelvin. Despite being 315 light-years away from the Sun, its brightness is sufficient to rank it 2nd in brightness when observed from Earth, shining about 15,100 times brighter than the Sun. Canopus is also a very large star, with a radius approximately 71.4 times that of the Sun, which is about 49,700,000 kilometers. With this radius, it would take our SpaceScience spacecraft 1,040 seconds to orbit the star once. However, Mr. Tubo certainly won't do that, because after passing this star, we still have a very long journey ahead awaiting us. Now we will head straight to the supergiant star Betelgeuse. Currently, we are approximately 700 light-years away from the Sun. As you can see, Betelgeuse is a red supergiant star with a radius about 887 times that of the Sun. Therefore, its brightness is 126,000 times that of the Sun. When observed from Earth, Betelgeuse is ranked as the 8th brightest star in the night sky. Despite being less than 10 million years old, Betelgeuse has rapidly developed into a red supergiant star with an estimated mass about 11.6 times that of the Sun. Betelgeuse is predicted to become a supernova within the next 100,000 years. In 2019, Betelgeuse suddenly dimmed to the 21st brightest position, leading scientists to speculate that it might be approaching the end of its life cycle and could soon explode, creating a bright supernova in the sky. However, in May 2020, Betelgeuse returned to its usual brightness after a period of dimming, making predictions about its supernova explosion time challenging. When Betelgeuse eventually explodes, we will witness a spectacular light show created by the explosion. Scientists believe that we might even observe the explosion during the daytime, although its brightness cannot be compared to that of the Sun. At night, the brightness of Betelgeuse's explosion could potentially outshine that of the Moon. Despite its large size, Betelgeuse has a relatively cool surface temperature of about 3,500 Kelvin, much lower than that of the Sun. Currently, Betelgeuse rotates at a relatively slow speed of only 5.47 kilometers per second, so it will take approximately 36 years to complete one full rotation on its axis. Now we will pass by the Betelgeuse star. You can feel how beautiful this region is, right? Let me introduce it to everyone. This is the Helix Nebula, also known as NGC 7293. When observed from Earth, this nebula is located in the Aquarius constellation. Looking through the clock, you can see it is about 700 light-years away from Earth, making it one of the nearest nebulae to Earth. In terms of its appearance, it bears a resemblance to the Ring Nebula. Moreover, it is often referred to as the Eye of God because its shape is reminiscent of an eye, with an apparent magnitude of 7.6. Therefore, if you want to observe this celestial object from Earth, you will need the assistance of astronomical telescopes. According to scientists' calculations, the Helix Nebula has a radius of about 2.87 light-years and an estimated age ranging from 10,600 to 12,100 years old. As you can see, the central region of this nebula is quite bright. That's because it contains a white dwarf, which is the remnant of a supernova explosion. When our spacecraft passes through this area, we will feel quite hot due to the surrounding temperature reaching about 900 Kelvin, or 627 degrees Celsius. However, this temperature won't affect our spacecraft since it is specially designed to withstand the extreme temperatures of space. As we pass by the Helix Nebula, we're now on a direct course to the supergiant star Rigel in the Orion constellation. Look over there, can you see it? That's Rigel, a blue-hued beacon on the clock, currently showing the time at around 860 years. That means it's about 860 light-years away from the Sun. When observed from Earth, this star shines brightly in the night sky, ranking 8th in terms of brightness. Based on its size and brightness, scientists classify it as a blue supergiant. In terms of size, it's approximately 79 times the radius of the Sun, and in mass, about 21 times the mass of the Sun. Despite not being exceptionally large in size, its brightness is staggering, shining about 120,000 times brighter than the Sun. With such immense brightness, the surface temperature of Rigel reaches approximately 11,127 degrees Celsius, more than twice the surface temperature of the Sun. Surrounding Rigel, you can see 3 other stars exist. This is a multiple star system, with one binary star and one independent star among them. All 3 stars are relatively small compared to Rigel, but still larger than our Sun by at least 3 times. Rigel, a blue supergiant, is depleting its hydrogen fuel in the core. Through analyzing its properties, scientists have observed that the star has transitioned from a red supergiant phase to its current blue supergiant phase. It's a cosmic rule that the larger and brighter the star, the shorter its lifespan. Rigel, being relatively young at over 8,000 years old, is much younger than our Sun, which is about 4.6 billion years old. It's likely to end its life in a glorious supernova explosion. Scientists estimate that if such an explosion were to occur and observed from Earth, its light would be about 300 times brighter than that of Venus, equivalent to about a quarter of the moon's brightness. You'd feel like seeing 2 moons simultaneously from Earth. However, to date, scientists haven't been able to determine when the star will explode. Let's wait and see. Perhaps you'll have the chance to witness this star's explosion. Let's take a break before we continue our journey to other attractions. Currently, the clock is indicating around 960 years, meaning we are about 960 light years away from Earth. Stay calm. This is the warning from the spacecraft when we encounter an object with extremely strong gravitational pull. In May 2020, scientists discovered and announced a black hole about 1,000 light years away from Earth, called HR 6819. A black hole is an object that we cannot observe with the naked eye, but scientists have recorded its existence based on gravitational interactions with nearby stars. Observations show that one of these stars orbits the black hole with a period of about 40 days. HR 6819 is calculated to have a mass over 4 times that of the Sun and is the closest black hole to Earth that humans have discovered. Additionally, the black hole and its 2 companion stars are moving at a transverse velocity of 9.4 km/s, meaning they are moving away from Earth at this speed. The SpaceScience spacecraft will soon fly through the region of this black hole, HR 6819. Passing by the black hole HR 8619, we're heading straight to the supergiant star Wazn. This star is also known by another name, Delta Canis Majoris, because it is very bright and located in the Canis Major constellation. As you can see on the clock, this star is about 1/600 light years away from Earth. At this distance, when observed from Earth, the star ranks as the 37th brightest in the night sky. According to calculations by scientists, this is a white dwarf star with an F8 spectral type. It has a surface temperature of approximately 6,290 degrees Celsius, but shines with a brightness 82,000 times that of the Sun. This extreme brightness is due to its classification as a supergiant star. Calculations estimate that the star has a radius about 216 times that of the Sun. Although its surface temperature is only slightly higher than that of the Sun, its brightness is much greater. It's estimated that if Wazn were to replace Sirius in our sky, we would see it shining as brightly as half the brightness of the Moon. Regarding its mass, it's quite heavy, about 17 times the mass of the Sun. According to scientists' calculations, the star has stopped burning hydrogen in its core, and its outer shell is expanding. In the next 100,000 years, it will become a red supergiant, and eventually, it will end its life in a spectacular supernova explosion. Scientists still cannot accurately predict when this explosion will occur. Passing by the star Wazn, we are en route to the star Enelem. You can see that this is also a blue supergiant star, located about 2,000 light years away from Earth. According to estimates by scientists, the star has a mass about 40 times that of the Sun and a radius about 32.4 times that of the Sun. Despite being at a considerable distance, we can easily observe the star with the naked eye in the night sky, with its apparent magnitude varying slightly from 1.64 to 1.74. When analyzed spectroscopically, it's classified as a B-type star. Hence, the surface temperature of the star is very high, estimated to be around 27,500 degrees Kelvin, much hotter than the surface temperature of the Sun. Because of its high temperature and large size, the star shines very brightly. According to estimates, its brightness is about 537,000 times that of the Sun. Please note that at the current distance of the spacecraft, we are very close to the star. Please avoid looking directly at the star, as it can cause harm to your eyes. Please use the protective glasses provided to observe it safely. Passing by the star Anilum, we have arrived at the NGC 6826 Nebula. This nebula is located within the Cygnus constellation, approximately 2,000 light-years away from Earth. It is known as a planetary nebula. Many people believe that planetary nebulae contain planets within them, but this is completely incorrect. The term planetary nebula originates from the round shape of these nebulae as observed by early astronomers through telescopes. Therefore, the term planetary in planetary nebula is a misnomer and has no relation to any planets. Besides being known as NGC 6826, this nebula is also referred to as the blinking nebula. You can observe a very bright star at the center of the nebula. When scientists observe this nebula with telescopes, the light from the star overwhelms the light from the nebula. Therefore, they have to use a technique called averted vision to observe this nebula. If observed from Earth, you wouldn't be able to see this nebula because its apparent magnitude is 8.8, so you would need the support of astronomical glasses. Looking at the clock, our spacecraft has covered a distance of 2,000 light-years. This means we have traveled a distance of 2,000 light-years since departure. While this may seem like a significant distance to humans compared to the observable universe's diameter of 93 billion light-years, it is incredibly small. So, what lies beyond 2,000 light-years in space? Let's explore that together in our next journey. Wishing you a pleasant viewing experience. If you enjoyed the video, please like, share, and comment below to share your thoughts with everyone. And now please feel free to select the next video on the left or right side of the screen to continue unraveling the mysteries of the universe with space science. See you in the next episodes. Goodbye.